Hi everyone, welcome to the tutorial for MoReLab. Let us start the process by importing a video and extracting keyframes. So click on this video icon and select the video that you want to work on. For the purpose of this tutorial, I will go to user study videos and select the test video task 1. So then click on open and the video will be loaded in the movie panel. The movie panel is on the left side. So in this movie panel, you can see the information related to the video by clicking on the arrow icon. So on the bottom left side, you have extract frames button. Click on this button and you will see two methods of extracting keyframes. The first one is the regular method and the second one is network. In network, there is no need to supply any parameter and this is completely automatic. The second method is the regular method in which the user needs to provide how many frames user wants to extract. And this can be decided by looking at the total number of frames. Generally, you need to skip something like 10 frames. So for the purpose of this demo, I would like to extract 30 frames so that every 7th frame will be extracted. Click on this OK button and the frames will appear in the central top slide bar area. You can move the slide bar to view different frames. So now you need to look for the suitable viewpoints of frames to work on. You only need 3 or 4 images to work on. So I'm looking through different frames and I decide that image number 22, 24 and 20 would be good choices to work on. Now I will explain the usage of new feature tool. In order to add a feature, you need to press the left mouse button twice. So a double mouse click to add a new feature. The information about that feature is displayed in the feature panel on the right hand side. So I have added feature number 1 and after that I will add feature number 2 and then I would add feature number 3. So it is very important to understand on which locations you want to add these features. Generally, corners, holes and patterns on a surface are good locations to add features. Like any place that you can recognize across frames with your human eye, that is a very good location to add features. So now in this process, I'm adding all these different features and in order to do so, in order to add these features, you can also zoom into the picture with your mouse wheel and you can pan around the image with your right mouse button. So this should help you in adding features at many different places. So generally you need to add something like almost 25 or 30 features on each frame. The more features you add, the better it is. The more features you add on one frame and the more number of frames on which you add features, it would be better for the algorithm. But through a user study, we have come to the conclusion that it is sufficient to add almost 25 features on 3 or 4 frames for the algorithm to work on. Once you have added sufficient number of features on one frame, you can click on another image and start adding the features on this new frame. So I have my new feature tool selected and I come to the corresponding location and I add feature number 1. So after that I add feature number 2, feature number 3, the same process that we did in the previous frame. So I'm continuously adding these features. I also want to explain the usage of 2 more tools over here. These are basically the guiding lines tool and the step feature tool. So this one is for step feature tool and then the guiding lines tool. First, I will explain the usage of guiding lines tool. But in order to explain the usage of this tool, I want to add something like almost 15 features, first of all, because this tool utilizes the calculation of fundamental matrix. And for that, we must add a minimum of 8 features. But in order to have a good approximation of fundamental matrix, it is advised to add almost 15 features at least. So during I'm adding these features, I am continuously coming back to image number 20 to make sure the location of the features that I add, they should be the correct. Make sure that you are adding the new features at the correct locations. I have added 17 features which are sufficient for a good approximation of the fundamental matrix. So come over here and click on this guiding lines tool icon, and you can see a dialog that says that fundamental matrix has been computed. At this point, it is showing the guiding line for the last feature, which is the feature number 17. So this red colored line, we call it guiding line, and and the idea is that the feature would always lie on this point. So and it guides the user to add a new feature. So in order to explain its utility, I can come back to image number 20, and now that I have added 17 features, I would like to add feature number 18. So I come back to image number 20 and click on this feature 18. And when I go back to image number 22, I can see a guiding line for the feature 18. And I am guaranteed that the feature 18 must lie on this particular line. So I would add the feature 18 over here. So in this way, it helps the user to add the feature, to understand the location where the user should add the feature. So once again, I will do it for feature number 19. I come back over here, and once again I add it. So this is how guiding line tool is used. So now I would just simply like to switch off the guiding line, and for that I would click once again over here, and the guiding line has disappeared. Another tool that I want to explain the usage is this step feature tool. So in order to explain its usage, I would like to go on an empty frame, and generally if you have the normal new feature tool on your hand and you double click left mouse button, you will add feature number 1, a feature with label 1. But with this step feature tool, it will look at the maximum label of all the previous features. So in this case it is feature 29, and so it will add one increment to the maximum level. So if I double click, it will add feature number 30. So if I click here, it will add feature number 30, and similarly then it will goes incrementally like this, 31 and 32. So this can be useful in scenarios in which a feature in which you go to a new viewpoint, and in that new viewpoint there is no feature that is common with the previous new points. So you want to add completely new features. So in that scenario, the step feature tool might be useful. But in this particular video, we do not need it. Therefore, I would like to reset the frame. So I will hit Ctrl plus R to reset this frame, and I would like to come back to the image number 22. I would once again grab the new feature tool, and now I will start the feature marking process once again, and I will speed up the process. Now I have added corresponding features on image 22 as well. I want to show you another method of adding features that is relatively faster than what we have seen so far. And that is that you have added features on one frame. You can press Ctrl plus C to copy all these feature locations. And then you can go to an empty frame that does not have any feature and press Ctrl plus V to paste all the features on this new frame. It will try to place the features at the correct locations, but some of them will be placed at the correct locations, but most of them will not be placed at the correct locations. So you will have to manually adjust the locations of those features. So now I will start this process, and I will try to manually adjust the locations of these features. Once we have added all features, it is a good idea to save your project. So hit Ctrl plus S to save the project. And once the project has been saved, come at bottom right and click on this Compute SFM button at the bottom right. What this will do is that it will perform bundle adjustment and calculate the 3D positions of the points. So the green points are the estimated 3D points, while the white colored plus signs are the manually marked 2D feature points. So if these green points are on top of the plus signs, it means that the 3D estimation has been correct. And if they are not, then the 3D estimation is not correct. Now that we have estimated 3D point locations, we can make use of these different tools that appear in the toolbar. Next, I will explain the usage of these tools one by one. Among different primitive shape tools, let us start with the simplest one, and that is this rectangle tool. So rectangle tool is used to model planar surfaces. Like for example, we have this planar flat ground and we can fit a model. And in order to do so, we need to click on 4 features in clockwise direction. So now I'm clicking on these 4 features in clockwise direction. By doing this, it will estimate the best possible fit for the rectangle through the 3D points of these 4 feature points. The next tool is the quadrilateral tool, and what this tool does is that it just simply connects the 4 points. So just like the last tool, we will click on 4 features in clockwise direction, and I am using the same features that I used last time, and you can see that we will obtain a different kind of visual because it just simply connects the 4 points that we have marked. Here, I would like to explain the usage of anchor tool as well. So anchor tool is mainly used to translate a 3D primitive from one point to another point. And this can be useful in many different scenarios. And the 3D primitive can be a rectangle or a quadrilateral or a cylinder. So let's say we want to transform this rectangle from this point to this point. So what we will do is that we will carefully click on the green point and then we will click on a desired point. And this will translate the entire rectangle to that particular point that we have marked previously. Later on, I will give another example of the usage of this tool. This is the picking tool, and this picking tool can be used to select any 3D primitive. So you just click on the 3D primitive and its color changes from blue to green, and then you can delete it by pressing the delete button. Similarly, since I do not need this quadrilateral, I would also select and delete it. Now I will talk about these cylinder tools. So the first one is the center cylinder tool. And I just realized that I need to have one more point for this tool. So I would come back to the new feature tool and then I will add another feature. That will be feature number 29. So I will add this on image 20 and then I will have to do it on image number 22 and 24 as well. After that, I would have to click once again Compute SFM button to calculate the 3D structure once again. So now it's doing its processing and the newly estimated 3D points will replace the previously estimated 3D points. So let's just do the processing, and finally now we have a green point on for the feature 29 as well. So once again I would select the center cylinder tool, and basically we need to click on 3 points. So the first one is the center point, so I click on this point, and then the second one is the vertex point, and the third one is the radius point. And so a cylinder is a circle is estimated for it, and after that I can place it on different 3D points to have a view of the cylinder. So I'm providing the depth for the cylinder, and you can see that a cylinder has been estimated. The next one is the base cylinder tool, which is actually more useful in most cases. So in many situations it can happen that the center is not visible, like in this case. So we can make use of the points that are on the surface, like in this case. So I have these 3 points on the surface, and I will click on these 3 points, and then the algorithm will basically try to estimate a circle that passes through these 3 points. So once I click it, it estimates a circle that passes through these points, and after that I just provide the depth of the cylinder to have the final cylinder shape. Now I would like to talk about this curved cylinder tool, which is actually the most innovative and most important tool of MoReLab. So it relies on the idea of cubic Bezier curves. So we need to click on 4 different points to be able to estimate a curve. So I start from on this basically curved pipe, and I click on 4 points. After that, I will click on a green point to estimate a black colored curve. So now that we have done it on this frame, we can do it on other frames as well. So once again, I repeat the exact same procedure and click on 4 different points. And after that, I click on a green point to estimate the curve. Similarly, I can do it on another frame, which is image number 24. So similarly, I would mark 4 feature points once again and click on a green point to estimate a curve. Then I press key F to obtain an optimized curve, which is red colored in this case. And after that, I will need to provide the radius for the cylinder. So I will click on this green point to provide the radius of the cylinder. And you can see that a curved cylinder has been estimated for this pipe. So now I would like to adjust this curved cylinder to obtain a cylinder that perfectly fits the pipe that is underlying behind. So I would select this primitive and right click by mouse to see different options for translation, rotation, and scaling. So you can see all these different shortcuts. You can translate it, you can rotate it. So if you click on translate, a panel would open up that will ask you for different options. So I'm putting a very small number here, and that is why the translation is very small. So now I would put a relatively larger number so that I can observe some effect as well. So now I would like to bring it back to its original position. And since I already know the shortcuts of all these translations and rotations, I would just simply press key Y and Control+Y to be able to adjust its locations. And here we can also see the usage of anchor tool as well. For example, I click on this green point and I desire that this curved cylinder tool end should be at this green point. So I can click over there and then it translates to the green point. Since I do not need this curved cylinder tool, I will just simply select it and press delete. Now I would like to talk about the usage of measuring tool. So in the measuring tool, the first measurement is always the calibration measurement. And for that, we always need to have the ground truth value known. So the first measurement is always the ground truth, and we provide that ground truth, which is 55.8 centimeter over here. And after that, we can click on any green point and go to another green point to be able to estimate the distance between those 2 points. So we can click the distance between any 2 green points. Similarly, if we have some primitive, we can also measure the distance on that primitive, and similarly we can also measure the distance between a green point and the primitive as well. So in these different ways we can make use of the measuring tool. And now I would just simply like to get rid of this primitive. Lastly, I would like to talk about the feature matching tool. And this feature matching tool is used for automatic feature detection and matching. And in order to explain the usage of this tool, I would like to load another video. So I will click on this particular test MP4 video because this is a more simpler one, and extract frames as well. And so I need to decide how many frames I want to extract. I would once again look at the total number of frames. So these are 305, and I think let's just extract 30 frames, and that should be enough. So these frames appear in the central top scroll bar area. And so this particular feature matching tool is used for automatic feature detection and matching. And I can also do this matching on a particular selected region of interest. So in this case, my region of interest is only this checkerboard pattern. So I can do a rectangular selection for my region of interest. Similarly, I would like to do the selection on other frames as well, on the places where I want to do the features. And I would like to point out that this is not necessary that you select a particular region of interest, but in this particular example, it is useful. You can always do the feature matching on an entire frame as well. So in order to do the feature matching, you will need to press and hold the shift key, and then you move from one image thumbnail to another. So while you have pressed on image number 6, you hold the shift key and then you press on image number 7 thumbnail, and then it will perform the automatic feature detection and matching between these two frames. I would like to estimate the 3D structure from the 3 feature points. So now I have clicked shift on image number 7, and then while holding it, I go to image number 8 thumbnail, and the feature detection and matching is being done between image number 7 and image number 8, so that I can obtain feature locations on 3 different frames. After that, very similar to the last time, we will once again compute SFM. So click on the compute SFM button at the bottom right, and it will estimate the 3D structure once again. And this tool can be useful in scenarios when a user wants to do the entire feature marking process very quickly. So in these scenarios, it will be useful. Now I will just quickly pass through the remaining tools. So the first one is the move tool. Basically, this move tool is a common standard tool that you can find in other softwares as well. When you are in this tool, you cannot make any changes to the feature. So I'm clicking on these features, but no feature is being selected. So basically, this tool makes sure that you cannot make any any changes in the features. So then there is the exit project tool. You can save as well. Another option is to import a folder. So it is not necessary to import a video. You can just simply select a folder, and once this folder is downloaded, there is no need for the extract frames. Instead the images that are present in that folder, they will appear in the scroll bar area. So after that, we have the tool to open a project. So if you click on it, you can see different JSON files. So JSON file is the extension that you will select, and it will try to open that particular project. So you can see that I have imported another project. Then you can always create a new project as well. So with that, I would say that the tutorial for MoReLab has been completed. Thank you very much for your attention.